Okay, hopefully that went okay. Now what we're going to do is we're going to try and prepare for tomorrow's class or for the next topic by doing something called balancing complex half reactions. The half reactions that you were dealing with just now were relatively easy, because each half reaction only had one element involved in them. But that's not always the case. Sometimes half reactions have more than one element involved with them. Sometimes something is turning into a compound and it has to react with other things in order to do that. So what we're going to do is we're going to try and balance complex half reactions. So when we balance complex half reactions, we're still showing the gain or loss of electrons. I'm only going to show you half the process, like in the sense that we're only going to talk about one half reaction at a time. I don't want to overwhelm us, and we'll talk about kind of more complex things later on, either tomorrow or when we get back from the break. So a complex half reaction is very similar to a regular half reaction, except there's more elements involved in it usually. But we still follow our two laws, law of conservation of mass and then law of conservation of charge, okay? And so we're going to balance using, first of all, the conservation of mass. Now, what I mean by that is you're going to have some elements, and maybe there are different numbers of elements on both sides. You have to make them equal to each other. I'm going to write an example down on the board, and hopefully you'll see what I mean by when I say that. So our first example, leave a little bit of space up here because we're going to develop our rules as we go. I'm going to write the first half reaction down here. Sometimes if you take nitrate ions, so NO3, nitrate ions, sometimes those nitrate ions, under certain conditions, they can get turned into dinitrogen tetraoxide. So N2O4 gas. We've seen N2O4 gas before, just briefly in the equilibrium unit. But hopefully you can see here is that the NO3 negative, the nitrate ions, are turning into something. And let's just kind of double check what's going on here. If you work out the oxidation numbers, so oxygen's -2, that means the nitrogen has to cancel out 5 out of the 6 because we want a negative charge. So +5. And it's turning into N2O4. Well, if the oxygens are -2, that means the nitrogens have to be +4. So the nitrogens are going from +5 to +4. I know, and the oxygens aren't changing, so this is only showing half of the picture. We're only getting a gain in electrons from +5 to +4. This is not a complete redox reaction. So because it's a half reaction, we're allowed to add electrons at some point at the very end. So what we want to do is we want to balance using the law of conservation of mass. And we have to do it in a very specific order. We have to look at elements in a very specific order. You always want to deal with your non-oxygen and non-hydrogen elements first. That's the first thing you want to deal with. So we're going to take a look at our non-oxygens and hydrogens, and I'm going to see, okay, the only other element here is nitrogen. It can't be oxygen, it can't be hydrogen. We're going to look at nitrogen. I see one nitrogen on the left-hand side. I'm going to erase the oxidation numbers so that we're not focusing on that right now. One nitrogen on the reactant side, two nitrogens on the product side. So the only way to balance this is by placing a coefficient of 2 in front of the nitrate, our reactant side. And as soon as we do that, the nitrogens will be balanced, but the oxygens won't be, okay? And we'll do that in a second. So then, these complex half reactions are always done in what we call an acidic solution. And so that because they're done in an acidic solution, and I'll just write this kind of down over on the side here. When I say acidic, I don't know what thing pops into your mind, but the thing that pops into my mind is either hydronium or hydrogen ions. Now, because we want to simplify this, we're going to go back to our Chem 20 definition of acids. And so we're going to say H+. So there is H+ available. We can put H+ on either side of this reaction if we need it, because it's done in an acidic solution. Now the other word, solution, well, we should know that a solution means that we have water available. And so we can balance this reaction by adding water molecules on either side, wherever we need them, depending on the circumstances. So balance your non-oxygen and non-hydrogen elements first. Okay, we did that. 1 nitrogen, 2 nitrogens, so we're going to place a 2 in front of this. But now we've got 2 times 3, 6 oxygens on one side and 4 oxygens on the other. We want to balance oxygens using water. So I see that I've got 6 oxygens on the one side and only 4 oxygens on the other side. So I need to add 2 oxygens in the form of water on the product side. So that's great. 6 oxygens, 4 plus 2 is 6 oxygens now. Then kind of finally for the conservation of mass, we want to balance hydrogens using H+. And remember, these things, they can go on either side depending on where we need them. So I don't see any hydrogens on the left-hand side, on the reactant side, but I do see 4 hydrogens on the product side. So if I have 4 hydrogens on one side and none on the other, I need to add 4 hydrogens on the left-hand side. And then the very last thing that I need to do, because I've balanced all of the elements, so my law of conservation of mass is done. Now I need to balance using the law of conservation of charge. And what we want to do is we want to add, same thing as before, same thing as earlier, electrons to the more positive side. So we have to add up all of our charges. Charges are really important. It's super easy for people to miss charges when they're writing down a chemical reaction. So just pay really close attention to your negatives and your positives. And I totally empathize with you. I get it. We haven't really focused on that yet. So on the left-hand side, on the reactant side, and then on the product side, we have to add up all of our charges. I've got 4 positives, so I've got plus 4, and I've got 2 negatives, minus 2, so that's plus 2. On the product side, I've got a total charge of 0, so I've got plus 2 on one side and 0 on the other. I need to add 2 electrons to the more positive side. So I'm going to add 2 electrons to the more positive side. Now, is this thing being oxidized or being reduced? Well, there's 2 ways to figure it out. You can take a look at the oxidation numbers. Remember, nitrogen was going from +5 to +4. So it's becoming more negative. It's gaining electrons. Another way to figure that out is that the thing that we're starting with is gaining electrons. So this is a reduction half reaction. This particular half reaction is a reduction half reaction. The nitrogen is being reduced. It's going from +5 to +4. We'll talk more about that a little bit later, tomorrow or after the break. Okay, let's do another one. Sorry if I erased that too quickly. Pause the video and reverse it. I don't know, reverse it, what a dumb thing to say. Rewind it if you have to take a look at it again. Okay, we're going to take a look at another reaction, another half reaction. This one's going to be a little bit more complicated, okay? So we're going to take chromium 3+ ions. And under very specific conditions, they can be turned into something called a dichromate ion. If you look in the table of polyatomic ions in your data booklet, in where your periodic table is, so if you look in the table of polyatomic ions right here, you'll see dichromate, and dichromate ions they are Cr2O7 with a 2- charge. Perfect. So let's take a look at this, but let's not deal with oxidation numbers. We don't need them right now. We can just assume that this is either oxidation or reduction. We'll figure that out a little bit later. So what we want to do in order to balance this complex half reaction, we want to do the law of conservation of mass and then the law of conservation of charge. So when you do the law of conservation of mass, balance all non-oxygen and non-hydrogen. So you can't do oxygen, you can't do hydrogen unless you do the other element first. So I see chromium, a single chromium on the left-hand side, but 2 chromiums on the right. So I'm going to toss a 2 in front of it. So 2 chromiums and then 2 chromiums. Great. So the non-oxygen, non-hydrogen is done. Because this this reaction is occurring in an acidic solution, we have access to hydrogen ions and water. We're going to deal with the oxygens first, because when I add water, I'm going to change the number of hydrogens. So deal with hydrogens just before you add electrons. So 7 oxygens on one side, no oxygens on the other. So I need to add 7 water molecules to the reactant side. Now I've got 7 oxygens, 7 oxygens. Great. So the chromiums and the oxygens are done. But because I added water, I introduce hydrogens. I've got 7 times 2 is 14 hydrogens. And there's no hydrogens anywhere else in the reaction. So I need to add 14 hydrogen ions on the product side. Because these are hydrogen ions, they're not elements. It is not H2. H2 is only hydrogen as an element. Okay, perfect. So we're done the law of conservation of mass. Check. The chromiums are good, the oxygens are good, and the hydrogens are good. Now I have to calculate all of the charges, and then I have to balance the charges. So let's take a look at this. My total charge on the left-hand side is 0 plus 2 3s, 2 positive 3s. So 2 times positive 3 is positive 6. On the right-hand side, on the product side, I've got 1, a coefficient of 1. 1 times negative 2 is negative 2. And then I've got 14 positive charges. So 14 are coefficient times positive, because there's 14 of them, plus 14 equals positive 12. So positive 6 versus positive 12. positive 12 minus positive 6. The difference between them is 6 electrons. So I need to add 6 electrons to the more positive side. So I'm going to add 6 electrons. So that brings my total charge on that side down to plus 6, and now they're the same. So now that reaction is, that half reaction is balanced. Let's try and figure out if this is an oxidation or a reduction reaction, half reaction. So I'm not gaining any electrons. Electrons are not on the reactant side. Nothing that I'm starting with is reacting with electrons, but we're producing something and we're also giving away electrons. So this is losing electrons. I was going to point to something that doesn't exist anymore. Losing electrons is oxidation. So this is an oxidation half reaction. You just say oxidation. It's totally fine. So the chromium 3 plus is being oxidized. Okay, no problem. So we're going to do one more example if you feel like you need to. Listen up if you feel like you need to. Otherwise, you can move on to some of the practice that's on the back of that sheet that you were given a little bit earlier. The last reaction that we're going to deal with is hypochlorite ions. If you look at your table, in your periodic table again, it's called hypochlorite. And if you look at hypochlorite, it's spelled 2 different ways. That's totally fine. So it's OCl minus. Hypochlorite is one of the things in bleach. It's one of the things that makes bleach bleach. So hypochlorite can be turned into chloride ions. Remember, chloride is the Cl negative ion. So what we're going to do is we're going to follow our rules. We've got to do conservation of mass first, and then conservation of charge. Conservation of mass, you always do the non-oxygen and non-hydrogen elements. So the only other element in here is chlorine. 1Cl, 1Cl. Good. That's great. So the non-oxygen, non-hydrogens is done. Then we got to do the oxygens. 1 oxygen, no oxygens. So I'm going to add water. So 1 oxygen and 1 oxygen now. Good. The oxygens are balanced. Then I'm going to add hydrogen ions because it's in an acidic solution. So we have access to hydrogen ions and water. I see no hydrogens, 2 hydrogens. So I'm going to add 2 hydrogen ions. So 2 hydrogens now, 2 hydrogens now. Our mass is done. This reaction follows the law of conservation of mass, but it doesn't follow the law of conservation of charge yet. When I look at the reactant side, it's 2 plus on the left here, and then another negative. So plus 2 minus 1 is plus 1. And on the product side, it's a total of minus 1. Now, if you have a plus 1 and a minus 1, are those charges already balanced? Are they already equal to each other? No. Plus 1 and minus 1 are not the same thing as each other. So what's the difference between plus 1 and minus 1? Go ahead and put in your calculator. Plus 1 minus negative 1. So plus 1 minus negative 1. So plus 2. So there's 2 electrons difference between these two things. You need 2 electrons, and you've got to add them to the more positive side. This is the more positive side, so I've got to add 2 electrons. Now, my total charge is not plus 1 over here. It's minus 1, and so the charge is balanced. Is this oxidation or is this reduction? Well, the thing that I'm starting with, my reactant, is adding electrons to it. It's not giving away electrons, so it's gaining electrons. So this is a reduction half reaction. So you got plenty of practice. You should have lots of practice on the back side of the sheet that you were given. Sorry if I ranted and rambled for a really long time. I apologize about that. Let Mrs. Cunningham know if you have any questions, or let myself know if you have any questions tomorrow, something like that, or overnight you can email me or something like that. Okay, let us know. Otherwise, have fun. Remember, conservation of mass first, then conservation of charge. Do the non-oxygen hydrogen element first, and then oxygens, then hydrogens, then electrons. Okay, bye. Have fun.